Today we learned about writing equations in slope-intercept form given real-world situations. For instance, a taxi company charges $5 to pick you up, then charges $1.10 for each additional mile. So if we were to write the equation of this in slope-intercept form, it would look like y equals $1.10 times x plus 5. Because we started at 5, no matter what. When you call the taxi, they're going to come to your house and you're going to have to pay $5 even if you don't get in the cab. Then for every additional mile, it's going to be $1.10. So the x represents the miles and the y represents the total cost or the money. So how much would it cost you to take a 20-mile taxi ride? We're going to plug in our 20 miles in for x because x equals our miles. So y equals $1.10 times 20 plus 5. So our total cost for the 20-mile ride is $27. How much would it cost for a 30-mile ride? Same thing, we're going to plug in 30 miles for x. So y equals $1.10 times 30 plus 5. Which is $38. Now, if your total bill was $49, how many miles did you travel? Well, $49 represents the total cost, so we're going to plug 49 in for y. So this time we have 49 equals $1.10 times x plus 5. Subtract 5 from both sides, we end up with 44 equals $1.10x. And to get x by itself, to find out the number of miles, we're going to take 44 and divide it by $1.10, which gives us a total of 40 miles that we've driven. Now to graph this, you're going to use your slope-intercept form. Y equals mx plus b. So y equals 110x plus 5. On our x-axis, we have the miles, and on our y-axis, we have the money. Y equals 110x plus 5. So we start with our y-intercept at 5. 1, 2, 3, 4, 5. And then this is the same as 110 over 1. So here is $1, a little bit more over 1. $1, a little bit more over 1, and so on. So we end up with a positive correlation. Second example, the U.S. Post Office charges $6 to mail a priority package plus an additional $1.50 per pound. So the equation for this one would be y equals 150x, we don't need the 0, you can put it if you'd like, plus 6. So to walk into the post office, it's going to cost you $6 for the package, and then it's going to cost $1.50 for every single pound. So the x in this one represents the pounds, and the y once again represents our total cost. How much would it cost to send the package that weighs 4 pounds? Well, let's plug it in. Y equals 1.5 times 4 pounds goes in for x plus 6. So it's going to cost us $12. How much would it cost to send a package that weighs 10 pounds? Y equals 1.5 times 10 plus 6, or $21. And lastly, if we know how much the bill was, $36, how much did the package weigh? This time we know our total cost, but we want to figure out how much the package weighs, so we're going to plug 36 in for y. So 36 equals 1.5x plus 6. Subtract 6 from both sides, and 30 equals 1.5x. Divide both sides by 1.5, and you have a total of 20 pounds that the package weighed. Once again, to graph this, we're going to use our slope-intercept form. Y equals 1.5x plus 6. y equals 1.5x plus 6. Our x-axis represents the pounds. Our y-axis, once again, represents the money. So we're starting with our y-intercept at 6. 1, 2, 3, 4, 5, 6. And then 1.5 is the same as 1.5 over 1. So for every $1.50 that we go up, we go over. So for every pound is $1.50 more. So $1.50 over 1, $1.50 over 1. We can simply see that it is also a positive correlation. Our next example is about a cell phone. A cell phone company charges $20 a month for service. They also charge an additional 10 cents per text. So we're going to have y equals 0.1 or 10 cents per text, so 10 cents times x, plus $20. So that means if you don't send any text messages, you're still going to pay $20 for your monthly service. But for every additional text message you send, it's going to cost you an extra 10 cents. So in this case, x represents our texts, and y, once again, is our total cost. How much would it cost you if you sent 35 texts during the month? Well, our text message is x, so I'm going to plug it in. Y equals 0.1 times 35 plus 20. So y equals $23.50. So it cost us about $23.50 for that month. Now, let's say we only had $80 to spend per month on our cell phone bill. How many texts could you send? This time our total cost, 80, goes in for y. So 80 equals 0.1x plus 20. Subtract 20 from both sides. 60 equals 0.1x. Divide both sides by 0.1, and x equals 600. Now this sounds a little bit more manageable for some of us 8th graders out there who like our texting. 600 text messages a month for $80. To graph this, we're still going to use our slope-intercept form. Y equals 0.1x plus 20. Y equals 0.1x plus 20. Now when looking at this 0.1, we can write that as a fraction because it's actually 1/10. So we could say y equals 1/10 x plus 20. Therefore, when we're using our graph here, the x is our text, the y is still our cost. So let's go up to 20. Let's see if I've got enough here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Barely. So I'm going to count by twos. So let's do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So let's start here with 20. And if I go up 1, remember I'm counting by 2, so it's in between, up 1 and over 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up 1 and over 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can see that it's still a positive correlation, but the line is not very steep at all. So 1/10 is a very slight slope, whereas the other ones that we saw were going up much more, this one's more gradual than the other ones are. Our last example deals with the NFL. An NFL defensive lineman current weight is 345 pounds. He is starting to diet to lose 3.5 pounds per week. So we want to come up with an equation that represents that situation. So we know that if we're losing weight, that's going to be a negative. But where does that negative go? Is it going to go in between, or is it going to go in front of the 345 pounds or the 3.5 pounds per week? You have to think about, where is the lineman starting at? He's starting at 345 pounds. That's a positive amount. So when we're writing our equation, we know that he's starting at a positive 345 pounds. If he's losing 3.5 pounds per week, that's going to be our negative, 3.5x. So in this case, we know we've got a negative slope. So the x in this one represents the weeks, and the y represents the total weight. How much would he weigh after dieting for 6 weeks? Well, if the weeks is our x, we're going to plug it in. Y equals negative 3.5 times 6 plus 345. So we want to know, where is our lineman going to be at after 6 weeks' time? And he's going to be down to 324 pounds. Now, the lineman needs to get to 305 pounds by the start of the season. So we want to know how many weeks he's going to need to diet. Because obviously at 6 weeks, he's not down to that goal weight yet. So the 305 is going to go in place of our total amount, or y. 305 equals negative 3.5 times x plus 345. Subtract 345 from both sides, and we end up with negative 40 equals negative 3.5x. Divide both sides by negative 3.5, and we end up with approximately 11.428, and so on. Now, the question asks, how many weeks does he need to diet? If he diets for 11 weeks, has he hit his goal of 305? No. So then, to answer our question, we're going to have to say he's going to have to diet for about 12 weeks in order to hit his goal of 305 pounds. To graph this situation, we're going to use our slope-intercept form. Y equals, I forgot my equal sign up here, y equals negative 3.5x plus 345. Y equals negative 3.5x plus, I'm off the page, come down here. Y equals negative 3.5x plus 345. We said that our x represented the weeks, so that's what our x-axis is going to be. And the y represented the total weight. So that's what our y-axis is going to be. Now for this one, our weeks I would count by ones. And actually I'm going to count by half of a week since we've got 3.5 here. So let's do 0, 1, 2, 3, 4, 5, 6, 7. So we leave a little bit of space in between. And I'm going to count by 25s for our weight. So this would be 25, 50, 75, 100, 25, 50, 75, 200, 25, 50, 75, 300, 25, 50, 75, 400. So we've got to make sure that our scale, it's not always going to be a one-to-one scale. So we're going to start at 345. So here's 300, 25, 50. So it's right here below 350. And we're going down 3.5 pounds per week. So for 6 weeks, we said he was at 324 pounds. So let's go out here to 6 weeks and come up to 324, which is right here below 325. And then we said at about 12 weeks, he was going to finally be down at about 305 or 300 pounds. So we can see that it's a gradual change, but it is a negative correlation, negative relationship. But he's losing weight, which is why we can say that it's negative. So your homework this evening is to look at the jet ski problem and determine what type of relationship they are. Write your equations to represent the relationship, the linear relationship between the number of hours you're renting the jet ski and how much it costs, and to graph those relationships and answer the questions that go with it. If you have any questions, please feel free to send me an email and I'll get back to you as soon as possible. I look forward to seeing you in class tomorrow.